Solving an absolute value equation in one variable. Okay, so again, we're solving. So when I want you to think of solving, that means we want to get the x term by itself. So right now, the x is locked in to that absolute value, and that absolute value is like jail. Nothing can get in, but it can get out. So again, let's go ahead and let's talk about GEMDAS. So we're solving. There's nothing I can simplify on the left side. So that means I'm going to do GEMDAS backwards because I'm solving. So I need to ask myself, looking at this x term, which is locked in jail right now, do I have anything being added? That's my first question. Do I have anything being added or subtracted to what's highlighted in yellow? And the answer is yes, this -1. So I have to add 1 to both sides of my equation. So that gives me 3 times the absolute value of x plus 2 is equal to 9. So I still have my absolute value. My x is still in jail. I've looked, something was being added or subtracted to it, I got rid of it. So now I have to ask myself, is anything being multiplied or divided to my yellow thing? The answer is yes, the 3. So that means I have to divide everything by 3. 3 divided by 3 is 1. So now I have the absolute value of x plus 2 is equal to 9 divided by 3 is 3. Okay, so it's very important that you do this step first. You have to get the absolute value alone. So I'm going to write that here. Get absolute value alone. Very important. So once we've done that, then we can go ahead and we can set up our two cases. So we have case 1, which is our as is, and we have our case 2, which is our opposite. Okay? So case 1, this is now where I take it out of jail. So it's x plus 2 equals 3. So I'm going to solve for x. I subtract 2 from both sides of the equal sign, and I get x is equal to 1. That is one solution. So now I need to do the opposite. So if I have x plus 2 equals 3, the opposite of x plus 2 would be this whole thing times a negative, -1. So then that gives me negative x minus 2 is equal to 3. Very similar, just different signs. I'm going to add 2 to both sides. I get negative x is equal to 5. I cannot have negative x. I have to have x. So if you remember, this negative is the same as -1. So I can either divide or multiply by -1. I'm going to go ahead and multiply by -1 because I want you to start getting used to seeing that. So that means now negative times a negative is a positive. So I get x is equal to -5. So that's my other answer. So now I have to graph these. There's one answer. There's two answers. Okay? So now I have to graph these. So I only have exactly 1, exactly 1, and exactly -5. No other numbers will work, so I don't draw any lines. So if you remember from before, we take our answers from here and we just plop them into our set builder notation. We do want to maintain number line order. Because -5 is smaller than 1, we're going to write this first. So the set of x such that x is -5, and we can see that right here, or x is 1. And we can see that there. The word or is important. Then we're going to do interval notation. So it's exactly negative 5. So it can equal negative 5. It's exactly 1. So it can equal 1. I have this big gap in the center. So I put this U-like symbol, which means or. So I'm done. That's how I answer my question.